the problem we are going to take now is a very popular problem. Okay, so listen to it very carefully. It has a bit long statement. So it says that there is a farmer. Some of you might have seen this question. It's great. So there is a farmer, and this farmer has n stalls. Okay, so he has got n stalls. Stall is just like a place in which he can keep a cow. Okay, so in one stall only one cow can be there. Okay, so basically you can assume that the number of stalls that this guy has is greater than or equals to 2. Okay, number of stalls are greater than or equals to 2. Now these stalls that he has, all of them are located on a line. Okay, all these stalls are located on a line, and their locations are at x1, x2, x3, x4, x5, x6, and so on. Okay, so all these stalls are lying on a line, okay, in a linear way, and the separation between them can be non-uniform also. Okay, separation can be non-uniform, right? So it is not necessary that all the stalls are equally separated. Some of them can be very close and some of them can be very far from each other. Now this farmer also has C cows with him. Okay, so he has C cows with him, and you can assume one thing, that the number of cows that this person has is smaller than equals to n, because one thing is obvious, that one cow can be accommodated in one stall only. So there is one-on-one relationship between stall and cow. You cannot have one cow in two stalls or two cows in one stall. Okay, so what you have to do is, you have to place these C cows across these n stalls. Okay, so place C cows across n stalls, okay, in such a way such that minimum distance between any two cows is maximized. Such that minimum distance between any two cows is maximized. So I repeat the question again. See, start looking from the beginning. Farmer has got n stalls, okay, and number of stalls is greater than equal to 2. You can assume that, okay. Second thing is that the stalls have got locations on line, like x1 equals to 0, x2 equals to 3, x3 equals to 9, x4 equals to 10. Okay, these are the locations of stalls on a number line. Now these stalls are non-uniform. I mean, distance between them can be non-uniform. The farmer also has C cows with him, and the number of cows is lesser than the number of stalls, lesser than or equal to the number of stalls. And for every stall there can be only one cow. I mean, you cannot have more than one cow in a stall. Either you leave a stall empty or you just have a cow in that. Okay, so you have to place C cows across these n stalls in such a way that minimum distance between any two cows is maximized. So I'll try to make it clear for everyone. So guys, first step is to understand this statement very clearly, okay, because now you have to get used to such kind of statement which asks you to minimize the maximum or maximize the minimum. Okay, you have to be very clear about this. So how you can think of it is, see, let's say there were 6 stalls like this, 6 stalls, and let's say there were 3 cows. So the farmer would have had multiple ways of keeping 3 cows across these 6 stalls. Do you agree to this? Yes, no? There would be multiple ways of accommodating these 3 cows across these 6 stalls. So one way could have been like this: cow 1, cow 2, cow 3. Other way could have been cow 1, cow 2, cow 3. Okay, another way could have been cow 1, cow 2, cow 3. Now let me call this as way 1, this as way 2, and this as way 3. Now just focus your attention on a particular way, and in that you figure out the minimum distance between any two cows. What is the minimum distance between any two cows in the first way? Let me write other values. Let's say this is 15 and this is 18. So what is the minimum distance between any two cows in the first way? So here the minimum distance between any two cows is, the distance between these two cows is 3 units, and distance between these two cows is 9 minus 3, 6 units, and minimum of them is 3. So for this way the minimum distance is 3. Okay, now without making any mistake, can somebody tell me the value for this? What will be the minimum distance between any two cows in this configuration? It will be 7, right? And what is that? That is the distance between cow 1 and cow 2. 10 minus 3 is 7, which is distance between them, and between them the distance is 18 minus 10, which is 8. Minimum of them is 7. And what will be the answer in this case? What is the minimum minimum distance between any two cows in this case? The minimum distance between any two cows in this case is this much, right? And what is this? This is 10 minus 9, 1, because this was 9 minus 0, 9. So here it was 1. Okay, so you think in a way that every way is being identified by this kind of number. And what is this number? This is the minimum distance. Now you have to find that way. You have to find that way for which this number is maximum possible. So this way you can, this is what the intent of question is, that out of all the ways that are there, in which way you will be having the minimum distance between any two cows as maximized. So tell me, what can be the way to solve it? So I think the easiest way could be that you can figure out all possible kind of arrangements. Okay. Now how you do that I am not going to take into account right now. So you can figure out all possible kind of ways, and for each way you can figure out the minimum, and whatever way had maximum value of minimum, that would be your answer, isn't it? That would be the easiest way in which you can solve it. But if you go by solving it, it will take you a lot of time, because there can be many different ways. How many ways will be there, by the way? Can somebody tell me? If their number of stalls is n and number of cows is c, capital C, it will be NCC, right? Because number of ways in which C cows can be kept at n stalls is NCC, and this thing can be quite large for very large n, right? So this is not a great approach. So guys, I'll first give you an example and then you tell me the answer for that case. Okay, so let's say the stall locations are like this: 1, 2, 4, 8, 9, and number of cows is 3. Can somebody tell me the output for this case? 3, right? So, and can you also write the stall locations, the x coordinates of stalls where you are, the x coordinate of stalls where the cows are being kept? 1 for 9, right? And that is correct, because if you place first cow here, second cow here, third cow here, this distance is 3 and this distance is 5. Okay, and what is the minimum of these two? That is 3. And this is the maximum possible value of minimum distance that you could get. If you change arrangement in any way, then whatever value you will get, that will either be 3 or that will be lesser than 3. Okay, so let me tell you, if I say that, hey, I pick a random number d, okay, and this d denotes distance, okay, distance between successive cows. I've used the word successive, means adjacent cows. So I'm going to say that, hey, I will be keeping cows in a way that the distance between them is at least d. At least d. Okay. So by that I mean, let's take this case. If I had fixed my d as 5, okay. If you fixed your d as 5, then you are saying that, hey, the way in which you are going to place the cows, it should be such that distance between any two successive cows should at least be D. It can be greater than D also, it can be equal to D also, but it will never be smaller than D, right? So if let's say the value of D was 5 and let's say I had placed my first cow at stall 1, where would I need to keep my second cow? Where would I need to keep my second cow? At 8, right? Definitely at 8, yeah, at 8 or greater than 8, because I could not keep it here or here, because the distance of this from here is 1, which is smaller than this, and the distance of this from here is 3, which is also smaller than this. So the second cow would have been kept here or here, right? But let's say there were few more stalls that were there. Now you have to ensure that at least this much gap is there, and also you need to ensure that all the cows are being placed, because you have to do that. That is the necessity of question. You have to place all the cows. So in this case, would you have placed second cow at 8 or would you have placed it at 10 or 11? Where would you have placed it? You would definitely have placed it at 8, because placing it as early as possible gives you an opportunity to place other cows also at the successive locations. So I have to place the cows in a greedy manner. Greedy manner simply means place them as early as possible, okay, and then ensure that the placement has been possible or not. So does that mean irrespective of what value of D I choose, I must always place my first cow at first location, which is first stall? Does it mean this? Yes, and that is common sense, because if you don't place it here and somewhere else, then that reduces a chance of ensuring that all the cows are getting placed, okay? In other words, if let's say there is an arrangement where the first cow was placed somewhere else, then there definitely will be another arrangement where first cow can be placed here also. So that is the reason you should always start by placing your first cow at first stall and then the remaining cows at remaining locations. Okay, by the way, let's say, come back to the case which was like this. If let's say I had set my D equals to 5, would I have been able to place all the 3 cows? Would I have been able to place all the 3 cows if I had set my D as 5? No. Is that clear to everyone? No. So if a particular value of D, the placement is impossible, will the placement be possible for D plus 1, D plus 2, D plus 3 and so on? It will not be possible. So this is the most important concept over here, that if you pick a particular value of distance and start placing all the cows such that gap between them is at least D, and for that D you could not do it, you will not be able to do it for higher values of D also. But if let's say you were able to place the cows at a distance of D, if it was possible, can I say that, hey, it would have been possible for D minus 1, D minus 2 and so on also? If you are able to place the cows at a distance of 3 each, and by the distance of 3 I mean at least 3, okay, it could be more than 3 also. So you can be able to place it at a distance of 2 also, right? Because again by 2 I mean at least 2. You can place them, right? So again, is this function also not a monotonic, right? Because if let's say for certain values of D, so whenever it becomes possible for me to place, I say that 1, I say that that distance is 1, and whenever it becomes impossible, I say 0. So let's say it was impossible to place them at a distance of D, then will all the other values also be 0? D plus 1, D plus 2, all of them will be 0. And if it was possible for me to place the cows at a distance at least, let's say this, which was D minus 1, it would have been possible for other values also, D minus 2 and so on and on. So this function is also monotonic. And what is the point that I need? This is the point that I need, isn't it? Cool. And now, can you write a function that takes a distance and returns true or false? stating whether or not cows can be placed at this much distance or not. Can you write that function? What will be the time complexity of that function? It should just be order n, right? Because you are placing the cows greedily. First cow at location 1 and then the second cow, you just keep checking whether you are able to place it or not. So whatever code that you are writing, not d+1, I mean you move across the array. You place first cow at array of 0 and then you start from array of 1 and find out the first point where second cow can be placed, and that is how you move on. And after the end of the loop, if you see that all the cows have been placed, then you return true, otherwise you return false. Okay. Now the function has been determined to be a monotonic function. Next thing is to determine the range, right? So what will be the range of answer? Can somebody tell me what will be the range of my answer? Whatever will be the minimum distance between any two cows in any arrangement, from what value to what value will it lie? Why don't you take this example only? Why don't you take this example? Minimum distance between any two cows. What will be the minimum distance between any two cows in this kind of condition? It will be 1, okay? And when will it be 1? When you place the first cow here and second cow here, okay? And what will be the maximum distance between any two cows? Maximum distance will be when you place the first cow at first stall and second cow at which stall? Second cow at last stall, right? So one more thing, this minimum distance, will it always be the difference of first two distances? Will it always be the difference of first two? So guys, think more before you answer it. No, it's not necessary. It's not necessary, because it could happen that I have stalls like this, 10, 20, 25, 35 and 50. So if this is the input, what will be the minimum distance? The minimum distance will be in between 20 and 5. So basically the point is, whatever will be the minimum distance, that will be minimum of the successive distances. Isn't it? Yes, no? Minimum of all the successive differences. So whatever is the minimum of all the successive differences, that can be the minimum value of my answer. Okay, what will be the answer for this case, you tell me? It will be 5, right? How will it be 5? Where have you placed them to ensure that the distance is 5? At 20 and 25, right? So one thing, can I say one thing? Whatever will be the minimum distance, that will be distance between any two successive stalls, right? So if I consider all the successive stalls and figure out what is the minimum value, that would be the minimum answer. So whatever will be the minimum distance, that minimum distance can be figured out in order n time. Can you figure that out? Can you figure this 5 out in order n time? Yes, you can do that, right? So that will be your minimum value. And what will be your maximum distance? Maximum distance will come to scene when you have two cows and first cow is placed here and last cow is placed here. So in that, the answer will be max minus min of the entire array. Okay, cool. So you can figure out the minimum value of your answer by inspecting all the successive gaps. It can be done in order n time, and maximum distance will be this minus this. Once you have these values with you, then you can simply apply the binary search and then your question will be solved. What will be the overall time complexity? Again, you are saying n log n. I would say that please take some time and think before you say n log n. It is not right to tell wrong time complexities. Doesn't it depend upon these two values? It depends upon those two values, which are low and high, right? I am not calling them min and max because min and max of array are different. So if I call this thing as low and I call this thing as high, which are the initial low and high, which are your range of answers, then number of iterations will be log of this, and for every iteration you are invoking this function. And how much time is this function taking? This function is taking order n time. So your solution will be of this complexity.